Hello and welcome to 10 Python procedures to commit to memory, a continuing sort of series I've been doing with various coding platforms, SAS, R, now Python. So let's get into them. So these are the procedures that I use a lot. I do a lot in Python in preparing data sets for further analysis in R or SAS, so that'll reflect that. These are certainly not all the things you can do, but I think these are helpful things that I need to do all the time, and it's helpful to try to memorize the general procedure rather than having to look it up if I haven't done it in a while. So, look at path and file designation, opening files, printing, for loops, splitting or stripping, if else statements, lists, dictionaries, functions, and concatenating. So, some of the color coding, I'll kind of follow the Python IDE. So, comments are in red, strings are in green. Keywords in Python are the orange, built-in or purple, and then definitions are going to be blue, and then the rest is black. All right, the data set I'm actually going to be using when I get to the live example is actually from Dryad. There is data from the article Discovery of a Multi-Species Shark Aggregation and Parturition Area in the Ba Estuary, Fiji Islands. So I'm able to get the bio data and turn that to a CSV file. And so it's a bunch of shark information. So that'll be a live example, and there should be a link to that data set if you want to play around with it yourself in the description. All right, so path and file designation. So certainly there's all sorts of ways to do Python, and if you dig into some of the Python training, you hear about things that are more or less Pythonic. I'm not going to really go into that here. I'm going to show you what I've done that is helpful for me conceptually, and we'll go from there. So a lot of things I'm doing is getting a file. So I typically create objects, what I call path and file. So the path is going to be the path to wherever my file is on my drive. And then, of course, my file, like cooldataset.cv or CSV. Obviously, if I'm working with multiple files, I might name them a little more specifically, like shark file or genomic file, or maybe just file one or two. And really, that's all I'm going to do is I'm going to set these strings of the file name and the path name to objects called path and file so I can reference them later. Next up is opening files. There's a couple different ways to do that. Now, you could just create an object called open file and then open your path plus file, though I find that I don't really use that at all, but I'm just showing that here for sort of completeness. But often what I use is going to be a for loop to loop through the file. So I'll say for line in open path and file. That's really nice. These are objects, so it concatenates them together, and then it'll open up and I can do what I want for that. But that for line in open path plus file is something I use over and over again. So it's good for me to memorize. And then whatever else I want to do from there goes on. All right, printing. That's obviously the big function. In the later Pythons 3 and up, it's going to be just print with parentheses. So you can print line, print variable, print list, whatever. And that's pretty straightforward. And so it's good to memorize that. And then for loops. We've already seen that before a little bit, but I use for loops a lot. And so it's helpful to constantly remember how to do those so I don't have to look that up. So it might look like when I'm working with a file for line, you could call it whatever you want, but line makes sense because there are lines of my file. It makes sense to me. So for line and open pass plus file, and then maybe I'll print the line. I'll do something to the line. And of course, it's not just files. Another common thing I might be doing dictionaries or lists. So I might say for I in my list. So the certain iteration, I'm going to print it or something like that. All right. That's a for loop. Splitting and stripping comes up a lot because, like I said, a lot of what I use Python for is running through a data set, formatting it, getting it ready for analysis. So splitting is really nice with especially things like comma separated values or tab separated values where each column is separated by something. So you can split everything out by saying, create a new object, which is in the top example is actually going to be a list or a variety of objects because you haven't specified anything, but you're going to do whatever your object is. So line dot split and then split by whatever delimiter is. So in a comma delimited file, that line is going to be split up by a comma. It could be a tab. It could be other things. If you want a specific variable from a specific point in your split, you can say you can have the brackets of that specific line there. Okay, if else statements that are also really important for my work here. See, you can do something as simple as checking a value of a variable, and if it set up, you can do that. Or you could mold out a if else statement. So do one thing for one thing or another for another. So you could print great one if the variable is greater than 10, else you print something else. And of course, it doesn't have to be print, it can be whatever you want here, but that if else statement going on. Now, one of the downsides to Python is you can't have like if elif statements, else statements like some other languages, but you can certainly nest if else statements as much as you want. All right, list, another big thing for me to remember and use. So you can make an empty list with the square brackets. You can fill it up with whatever you want. It could be all numbers, it could be a variety of different formats, it could be strings, numbered, integers, floating point numbers, Boolean statements. And it's really helpful to combine with other things I need to memorize, like the for loop. So for I in list two, you could append it from a different list or do whatever you want here. But that's important to remember. Okay, lists are by bracket. Similarly, dictionaries, an empty dictionary is the curly brackets. Sometimes I forget that, and then I try to make a dictionary as a list, and it doesn't work. And to add to a dictionary, again, this is something where if I don't do it for a while, I can forget this, how it's kind of set up. So there's going to be a key and the value, and it's going to be separated by the colon, and then different entries are going to be separated by comma. The keys have to be unique. The values can be different. And if I want to create a new entry in the dictionary, I can just say dictionary and then with the brackets, the new key and then the new value. Of course, you can update the values if you need to. All right, functions. I don't use functions as much as I probably should in Python, so this is a helpful thing for me to try to remember just how to set it up so I can do it more in the future. So you can use this define, call your function wherever you want, my function, and then in the parentheses, it can have its arguments. It can have as many as you want. It can maybe even have no arguments. And then within there, you're going to do whatever you want to it. You can, you know, do mathematical operators, formatting, and then you could return or print whatever you have from there. So that's the basic of a function. And finally, concatenating that we've already seen a little bit of that, with our file and path, but it's important for me to remember some of these things, especially when you're trying to like concatenate different types of objects. So say I can create objects called, there's strings, there's numbers, but then if I want to print the string and a second string, I can do that with the plus operator. And I can even have sort of a new string with an empty space so I can space out graded snakes. And if I want to concatenate something that's not a string with string, I need to turn that into a string. So I might use the string function on my number. So pretty straightforward. All right. With that, that was all pretty basic. Let's just do a quick example in action using that Shark data set. All right, here we are with Python idle. I have examples here in my script, and then I, of course, can run it in the shell. So I'm just going to walk through each of them and then run it all at once, and then we can kind of walk through here. Obviously, I could use something like Jupyter Notebook or Lab if I want to go one by one, but this is probably the best balance of sort of like approachability and ease. And I've been using this more than than those. So just take it as you will. All right. First one, path and file designation. So again, I have my path to where I have my data, fairly long. That's just a string, and then that file, that bio data, that's that shark data. Then with that, from there, I could, if I wanted to open the files, I could do it just by itself. I could create an object called O file and call open file, or I could just run open path plus file. So I find that that's only what I really do with an open file is using it for something, and we'll see that later on. If I want to print, I can print my path, print my file to make sure I did it right, or I can print the O file, though again, that's not terribly useful because it just shows sort of the details of it. Where it really starts to start cooking is when I get into the for loop. So if I say for line in open path plus file, that's that again the bio data, that shark data. I can print each line and I can see what my data actually looks like. From there, I could split and strip, start to actually work with the data, do something interesting. So if I go through, I know that one of the columns is going to be species. I know that's it's the third entry, so 0, 1, 2, I could split that and call an object species on the line split. And this is comma separated value, so you use a comma as the delimiter. I know my net position is the 10th column, so I could do 9 because we start at 0. Then from there, because I've sort of split these out, I could print the line, but then I could print the species and net position so we can see those separately. And then if I wanted to, stripping, you can strip out things like characters, white spaces, things like that. And one of the thing I know about net position is that it's actually the last entry, so it's going to have this new line character, and so I might want to strip that out if I don't want that to be carried on to whatever else I'm doing with it. If else statement, again, we're going to keep with the for line and open path file. Then I might say, well, I know I have my headers, my column names like date, area, etc. So I might say, well, if the string, the first couple entries, date, area, that's going to be my header. If that's in the line, pass it because I don't actually want to deal with that right now. And then I pass. Otherwise, I'm going to, find the method and split and print that out. So that often is what I do here is that I'm doing different things to the header than I am to the actual entries. Obviously, there's more ways to do with that, but this is my kind of methodology. For get to lists, there's a variety of things we can do. We'll continue the for loops, if else loops. So I can create an empty list called species list. And what I'm going to do is first, ignore the headers. Then I'm going to create an object called species by splitting the line. And then I'm going to check, if the species isn't already my species list, please put it in there. Please append it. And then I can see how many different species I have. But then maybe I want more than that. Maybe I want counts. So I'll make an empty species dictionary, do the same sort of thing. But then I'll say if species not in species dictionary, the key is going to be the species. So that's going to be unique. And then if it's not already there, I'm going to say, well, 1 is going to be the value. That's going to be the count. But if it's already in there, I want to do something to that. I want to actually append it. So update the dictionary. So I'm going to say species dictionary that value is going to be +1. And then so I can print that and see how many, not only the species, but how many of each. From there, I want to do a simple function. I want to go from centimeters to inches because I know the lengths of these juvenile species of shark are in centimeters, but I want inches. So I'll create a function here. It'll take one argument, cm length. And so it'll calculate the inch length from the centimeter length by multiplying by the correct factor. And then I can actually round that to make it a little tighter, and then I'll print that. That's the function. And then what I'll do is I'll, go through here, find this total length, do an if statement to make sure it's not a missing, NA missing. But if it is there, I'm going to turn it to a float and then can run that function within there so I can get all the inches. And then finally, concatenating. This is going to kind of be using almost all the things we've already done, sort of building up on here. We're going to do the for loop, get our path and file, date area. We're going to pass on that header. Then we're going to create an object for each line, species, total length. If the species is a certain species name, Mokaran, these are actually great hammerheads. If it's in there, I'm going to check with if it's sex. If it's missing, I'm going to pass. Otherwise, I'm going to set it from M to male or otherwise F to female. So I have a new variable with the fuller sex on it rather than just abbreviation. And then at the very end, you can see we start to nest if else loops. But then at the end, as long as sex is there and total length is not missing, I'm going to create a couple lines and then concatenate them together. And within each line, I'm concatenating different things. So I'm going to concatenate this string sex2 plus great hammer juvenile. And then line 2 is going to be, I'm going to take my length, but then turn it into a string and then centimeters in length, and then print the both together here so I can kind of get that information out. So that's what we did all here. Let's just run it and we'll kind of take a look at what that does here. All right, let's see what we've got here. So when we print we really don't have anything until we start to printing because otherwise these are just creating objects. So we have our path. When we print here, we have our file, and then we have just the open file, kind of all that goes into it, but really you want to just run open things. When we get to the for loop, so we say for line and open path as well, print the line. So it prints everything, including the headers. We see things like date, area, species, and then the actual lines with the data. It's quite a bit, go all the way down here. So then next we get to this splitting and stripping. So we don't print each line, but I run through this and I create a species and net position. And at the very end, this is outside of the loop, so it'll just print the last iteration of this. I say print line, so we reprinted the last line. We see all this information here. And then we had species and net position. We have Luini as a species, so that was 0, 1, 2. That was the second one there. And then 0, 1, 2, 3, 4, 5, 6, 7, 8. I think 9 is middle. That's the net position. And if we look at, yeah, so there we go. All right, if else statements. For this time, we just created method, and then we just printed method. We passed out on the date and area, we passed on the headers, and this just printed the method. So for all the different lines. More interestingly, we'll get to the lists. We had a list of the different species, and what we get out here is you see there's 3 different species, Luini, Limbatus, and Mokaran. But then with the dictionary, it's a little more interesting. We get the species and the count. So we see that most of them were Limbatus, followed by Luini, and then Mokaran. And on our functions, again, for each of these ones, we create a function to translate from centimeters to inches. And then we printed that for each of the lines. We see here 24 inches, that's about 2 feet. So these are juveniles. And so all the different things in inches. And then finally, we looked at our concatenate, and we did a lot of stuff here to just look essentially at those Moroccan or Morcarans. So those are juvenile great hammerheads, and we just looked at the ones with enough data on length and sex. And I believe that there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's 10. There's 11 total, but one had missing information. So we just printed the ones with that information. And we can see here that we pull out this string of, female great hammerhead juvenile, 74.9 centimeters in length. And then there's male, there's female, male. And so that gives us all the information there. All right, that was a quick example here. Again, we went through these 10 things to memorize. Hopefully that was a little bit helpful. Thanks for joining me, Mark Williamson. I will see you next time.